Okay, picking up with question number 29, find the center, major vertices, minor vertices, foci, and eccentricity. So again, the formula for an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. And again, if the a squared, which is always going to be larger, so a squared is always larger than b squared. If a squared is under the x, then it's oriented horizontally. If the larger number, the a squared, is underneath the y, it would be oriented vertically. So when I look at this one right here, I see that the 100 is underneath the x, so I know that this is oriented horizontally. All right, so I know that my major axis is horizontal, the foci will be on the horizontal. Because we have nothing being subtracted from the x and the y, I know that the center, actually, you know what, let's come back to the center. I know a squared is underneath the x, so a squared is 100, so therefore a is 10. I know b squared is 64, so b is 8. And in this case here, when we're given the formula, we're going to use the formula that c squared equals a squared minus b squared. That way we can just quickly calculate that c squared is 36, and so c is 6. All right, so we're all set now. So now let's go back to the idea that there's nothing being subtracted from the x or the y. So my center is at 0, 0, the origin. My major vertices are therefore horizontal. So I'm going to go left and right 10, that's A. So I get plus or minus 10, 0. My minor vertices are therefore going to be vertical. That's going to be up and down 8. And then our foci are on the major axis again. So they're going to be left and right 6, so plus and minus 6, 0. And then my eccentricity is c over a, and so as a decimal that is 0.6. And I will accept either the fraction, although you should reduce it, or the decimal version. The only purpose of the decimal is it allows me to tell how circular or oval, if you will, the ellipse is. The closer to 0, the more circular. The closer to 1, the more oval or elliptical the ellipse is. All right, looking at number 30, we have, because the larger number is underneath the y, this is oriented vertically. A squared is 49, so a is 7. B squared is 40, so b is going to be the square root of 40, which simplifies to 2 radical 10. And c squared equals a squared minus b squared, or 9, so c is 3. So now that we have all that, we can go calculate our center, and that's going to again be 0, 0. Our major vertices are therefore going to be up and down 7, so 0 plus or minus 7, again because it's oriented vertically. Then our major axis is vertical on the y-axis here. Minor vertices would be on the x-axis, so they are going to be plus and minus 2 root 10, 0. Our foci will be on the major axis, 0 plus or minus 3. And our eccentricity is a c over a, which as a decimal comes out to be 0.4286. So again, the big thing is looking at the a squared, finding the values of a, b, and c here so that we know how to go either left or right or up or down from the center. 31 and 32. So first of all, we need to get this into that standard form. So we're going to start by adding 225 to the right side, then dividing both sides by 225 because we need the 1 on the right-hand side. So 25 divided by 225 is 9. 9 divided by 225 is 25, so the y squared over 25. So again, here we are in standard form. From here, I can see that this is oriented vertically. That a squared is 25, so a is 5. Neaten that up a little bit. That b squared is 9, so b is 3. C squared is a squared minus b squared, so that would be 16. So b is, c, sorry, is 4. All right, so our center at the origin again, our major vertices are, because it's vertical, it's going to be up and down 5, so 0 plus or minus 5. Our minor vertices are going to be left and right 3. Foci on the major axis are going to be up and down 4. And our eccentricity is C over A, 4.8. 32 is done pretty much exactly the same way. Add the 36. Let's divide both sides by 36. I'm going to go ahead and 36 over 36 cancels. You can just have y squared there. Okay, so if you prefer to have just y squared, that's fine. It's a little bit safer, I think, to put the over 1. This way it's easy to identify the values that you need. This is going to be horizontally oriented because it's the larger number. The a squared is underneath the x. My a squared is 36, so a is 6. B squared is 1, so b is also 1. C squared is the difference, so 35, which means c is the square root of 35. Our center is at 0, 0. Our major vertices are going to be right and left 6, so plus minus 6, 0. Our minor vertices are 0 plus or minus 1. And our foci at plus or minus root 35, 0. Eccentricity is C over A, and that comes out to be 0.9860. Again, very close to 1. So these foci are going to be very close to the major vertex, which is going to give you a very kind of flattened out ellipse. All right, let's finish with numbers 33 and 34. A little bit more complicated here. Here we're going to actually shift the center away from the origin, plus we're given this longer equation that we're going to need to work with. So we're going to start by grouping our x terms, grouping our y terms, and moving the constant to the other side. That should be a 36x. Then we're going to go ahead and factor a 9 from the first two terms, giving us x squared minus 4x. Let's leave a little space here to complete the square. Factor out a 5 from the y terms. Leave yourself a little space to complete the square, and put the 4 over there on the right. Take half of the middle term, square it. It's plus 4, which is a net change of 36. So we need to add 36 to the other side. Half of 2 is 1, squared is 1, a net change of 5. So we now factor the left side, so I get 9 times x minus 2 squared, 5 times y plus 1 squared equals 4 plus 36 is 40, plus 5 is 45. Divide everything by 45 now. 9 over 45 simplifies to 5. 5 over 45 simplifies to a denominator of 9 equals 1. So larger number under the y, so we're oriented vertically with an a squared equal to 9. So a is 3. B squared equal to 5. So b is the square root of 5. C squared is a squared minus b squared. So c is 2. I'm going to scroll down. We'll scroll back up when we get to number 34 after. So our center is going to be positive 2, negative 1. Our major vertices are going to be vertically, so they're going to be up and down 3 from that center. If I go up 3, I get to 2. If I go down 3, I get to -4. Our minor vertices are going to be right and left the square root of 5. So we're going to have 2 plus or minus the square root of 5, comma -1. And then my foci are up and down 2 from our center. So I go up 2, I get to 1. Go down 2, we get to -3. Eccentricity is C over A. 2/3 is 0.6667. Question 34. Same process here. Group the x's, group the y's, move the constant. GCF from the x's, there isn't any, leave a space. Take a common factor from the y's. Half of 8 is 4, squared is 16. So there's nothing to distribute, so we just add 16. Half of -6 is -3, squared is 9. Because of that factor of 4, the net change is 36. And we factor, so x plus 4 squared plus 4 times y minus 3 squared equals, the 36's will cancel, leaving me 16. Divide through by 16. I get x plus 4 squared over 16 plus y minus 3 squared over 4 equals 1. This is horizontally oriented because the larger numbers underneath the x. A squared is 16, so a is 4. B squared is 4, so b is 2. C squared is the difference, so c is 2√3 square root of 12. So our center is at -4, +3. From there, we are going to go right and left 4. So if I go right 4, I get 0,3. Go left 4, I get -8,3. Minor vertices, we're going to go up 2, I get to 5. Go down 2, I get to 1. And then foci, we're going to go right and left 2√3. So -4 plus or minus 2√3, comma 3. Eccentricity is C over A, 2 Now, if you want to leave it as a fraction, do make sure you reduce. So it'd just be √3 over 2, which comes out to be 0.8660. And we'll continue with number 35 in the next video.